In today's lesson, we're going to start off by reviewing factoring. Factoring is an important concept that is going to be used throughout the rest of the semester, so the mastery of each type of factoring is going to be crucial in the following sections. When you factor, the first thing you should always look for is a greatest common factor. Once you find the greatest common factor between the terms, you will use what's the distributive property to remove that factor and write what's left in the parentheses. In the problem 4x squared minus 8x, I want to try to find a factor that goes into both 4x squared and into 8x. So the greatest common factor that goes into both of those is a 4x. So if I remove 4x out of 4x squared, you're really just dividing this by 4x to see what you have left when you divide. Well, the 4's are going to cancel, and then from our rules of exponents, we know if we have 2 on top and we take off 1 at the bottom, we're left with 1. Then minus, and then if we divide this by 4x, well, the x's are going to cancel, and then 8 divided by 4 is 2. So we just factored this, and we can check it by distributing it back. If I take 4x times x, I get 4x squared. And if I take 4x times negative 2, I get negative 8x. And I know this is factored completely because x and 2 have no other factors in common. Once you look at the GCF and you remove the GCF, then your next step is to count the number of terms that are left inside to see if you can factor anything farther. So the first one that we're going to look at is, what if we have 4 terms and there is no GCF that we need to remove out of it? We still are able to factor this by using the method of the GCF. So this is called grouping. So when you do grouping with 4 terms only, you're going to group the first 2 terms and then you're going to group the next 2 terms, the last 2. We are going to find the GCF of these 2 terms and factor it as we did in the previous example. And then we're going to find the GCF of these 2 terms and factor it. So let's start with the first one, 3x cubed minus 2x squared. We're trying to find out what factor goes into both this one and this one. So the highest factor that we can take out of these is an x squared. That is the only thing they have in common. What I'm left with, if I divide this by x squared, is a 3x. If I divide this by x squared, the x squares will cancel and I'm left with a 2. So the first grouping factors to x squared times the quantity 3x minus 2. Now let's do the same process with the last 2 factors, or last 2 terms. So we have 12x minus 8, and I'm looking for a number that goes into both 12 and 8. So that is going to be a 4. So I'm taking out a positive 4. And if I divide 12 by 4, I'm left with 3x. And if I divide 8 by 4, I'm left with 2. Right here you should notice that these parentheses end up being the same. If they're not the same, then either the problem is not factorable or you made a mistake. Now from here, if I look at this piece and I look at this piece, they have this in common, 3x minus 2. So it's actually the greatest common factor of both of these pieces. So I will take out the 3x minus 2. And then what I'm left with, if I divide this by 3x minus 2, all I'm left with is x squared. If I divide this by 3x minus 2, I'm left with a 4. So now I have completely factored this 4-term polynomial into the binomials 3x minus 2 times the quantity x squared plus 4.